All right, this 11, lesson 7.5, division properties of exponents. You're going to learn to divide powers with the same base and to raise a quotient to a power. Quick review here. The word quotient. Quotient means you're dividing two things. That will be shown there and there. Quotient of two negative integers is always positive. Quotient of two positive integers is always positive, and the quotient of a negative integer and a positive integer is always negative. Okay, let's just review some properties here. When you move the grouping symbols like this one, that is the associative property. This one, we're raising a power to a power. And the last one, when you add 0 to any number, you end up with that number. That's the identity property of addition. An example of the distributive property. Commutative property. And the identity property of multiplication. All right. So we're going to divide powers with the same base. To divide powers with the same base, subtract the exponents. And just let's talk about why that makes sense. Let's say we have 10 to the 6th, and we're going to divide that by 10 to the 2nd. Okay. 10 to the 6th means we are multiplying by the base 10 6 times. And then we're dividing it by the base 10 twice. So essentially, I'm taking away 2 of the times I multiplied by 10. So it makes sense that we just do 6 minus 2, which is 4th power. Because dividing, which is what subtracting exponents is doing, is taking away from the number of times that we multiply by. And another way you can look at it is this. Let's say I expand 10 to the 6th like that, and I divide it by 10 to the 2nd expanded, which is that. Well, every time I have 10 divided by 10, that's just 1, and the identity property of multiplication tells me that if I multiply 1 by anything, I end up with whatever I'm multiplying by. And so there's another 1 there, and I'm left with 1, 2, 3, 4. So it makes sense that we subtract when we're dividing as long as we have the same base. So what does that mean here? If we have c to the 12th, so we're multiplying by c 12 times, and then we divide by c 9 times, we're taking away 9 of the times we're multiplying by c. So that would be c to the 3rd. On this one, let's separate the bases out. We can do that with division. A to the 4th over a to the 6th times b to the 8th over b to the 3rd is the same. So we have the same base, and we're going to subtract 4 minus 6. And then we're going to do b to the 8 minus 3. And that's a to the negative 2nd times b to the 5th. And we don't like to have negative exponents when we're simplifying. Remember, a to the negative 2nd, it means 1 divided by a twice. And b to the 5th is just b to the 5th over 1. So we end up with b to the 5th over a to the 2nd. All right, go ahead, you try it. I'm going to pause here, and you can check back with your answers. Just wanted to talk about the last 3, see how you did on them, but is d to the 3rd divided by d to the 9th, is the expression always, sometimes, or never equal to d to the 6th? Well, I hope you're thinking we would do d to the 3 minus 9, which is negative 6. And there is one case where that would be true, that d to the 6 equals d to the negative 6, and that's when d is equal to 1. So we can say sometimes there. The next one, 13, if we take 6 minus 1, we get k to the 5th power. And if we take 2 minus 5, we get negative 3rd power. Well, j to the negative third power is the same as 1 over j to the third, so this will always be true. So we get negative 3 minus 5 is negative 8. That's true. 7 minus 2 is negative 5. That's not true. So again, we can say sometimes if both our bases are equal to 1, then it would be true, but that's the only case. And in this last one, if we take 4 minus 4, we get 0. Anything to the 0 power is 1. Y, negative 1 minus negative 5 is positive 4. And z, 8 minus 1 is 7. And then x to the 0 is 1, so that's always going to be true. All right. Let's use this idea when we're solving a problem of numbers written in scientific notation. Population of Pennsylvania is about 1.24 times 10 to the 7th. Population of North Dakota is about 6.4 times 10 to the 5th. That's changing though. North Dakota is it's growing faster than any state right now in population. About how many times greater is the population of Pennsylvania than North Dakota? All right, so we want to know, this is a division problem, we want to know how many times this population goes into this population. And we know it's a bigger number because that 1.24 times 10 to the 7th is bigger because it has a bigger power than this. So we should be able to divide that by that and get a number greater than 1. Now again, let's split this up. You can do that with fractions. I'm going to do 1.24 divided by 6.4 separate from 10 to the 7th divided by 10 to the 5th, because then I can use that new property for dividing when you have the same base. If I do 1.24 divided by 6.4, I get 0.019, and you could check this, but 375. And then I'm going to subtract 7 minus 5, and that'll be 2. And now, I think I'm just going to write that as a standard number. That 2 tells me I need to move the decimal over 2 places, so 19.375, but since we're estimating both these populations, let's just say it's about 19 times greater the population of Pennsylvania is than the population of North Dakota. All right, go ahead, you try it here. I'll pause, you can check that. At this point, I am going to I'm going to change this. I would not round to the nearest thousand. I would round to the nearest 100. And that's because in our original problem, that's rounded to the nearest 100, and so is that. So it makes sense to round it to the same spot. And if I do that, now I'm multiplied by 10 to the second, that moves the decimal over 2 places. So about 169 people per square mile. All right, here's another property, raising a quotient to a power. I think this one is another like distributive property of exponents. So if you have a fraction, say 3/5, and you raise it to a power, you really have to raise the numerator and the denominator to that power. That's the idea here, and here's why that makes sense. If I expand 3/5 to the third, I really get this. And so you notice I am multiplying 3 by itself 3 times and 5 in the denominator by itself 3 times. So both the numerator and the denominator have to be raised to that power. So this makes sense. 3 to the 4th is 81, 10 to the 4th is 10,000. If I do a negative exponent, that's the same as the reciprocal of that number to the positive exponent. And so I just get 10,000 over 81 the other way around. And so we're going to compare these. 5 to the negative third, well, that's 1 over 5 to the third. So that will be the same as that. 1/5 to the third. So 1/5 times 1/5 times 1/5, that's not the same as 5 times 5 times 5. In fact, it's a lot smaller. 3/4 squared, 4/3 squared, no. 3/4 times 3/4 is going to be smaller than 4/3 times 4/3. All right, 3/4 times 3/4 is the same as 4/3 to the negative second. It is, yeah, because that's equal to the reciprocal of that, the positive second. Those are exactly the same. Anything to the 0 power is 1. 1/2 to the negative third is the same as 2 over 1 to the positive 3, which is greater than 1. And again, here we have 1, but here we have 1/2 to the third. That's 1/2 times 1/2 times 1/2, which just keeps getting smaller, so 1 is greater than that. All right. Which of these is simplified 4? Now remember, the numerator and the denominator have to be raised to that power, so we're going to have to do this. And this to the third. Well, 4 to the third, that's 81. And then we're going to use our power to power property there. We're going to multiply those exponents. And so we're going to pick number, that one right there, letter A. All right, I'll pause so you can try that. All right, what is the simplified form of this? We're going to use this idea here, that anything with a negative exponent is equal to the reciprocal of that positive exponent. So right away we can get rid of this negative exponent by just flipping this over. And then we're going to do it like that. Then we're going to distribute that power to the numerator and the denominator. And so we get like that. And we have to distribute this power to both things inside there. So we get 3 to the 4th times c to the third to the 4th. And last thing I'm going to do is just 3 to the 4th, which is the number 81. And then a power to a power, 3 times 4 is 12. And we're done. Okay. Go ahead, you try that. Okay, again, some true-false problems here. 1/7 to the 4th. If we multiply 1/7 by itself 4 times, that will not be equal to 7 multiplied by itself 4 times. So that's a false. Number 31. Remember, that's equal to 7 over 2 to the third power, which is 7 to the third over 2 to the third. And 1/8 is the same as 1 over 2 to the third. So, yeah, those are the same. True. If we flip this 2 over 7 and then raise both of those to the second power, we get that. That's true. If we flip this 7 to the 4th, raise that to the 5th, and do 2 to the 5th. Do we get that? It doesn't look like we're going to get that, because we get 7 to the 20th over 32, and this one's going to be 32 over 7 to the 20th. Or 7 to the 20th is, so that one's false. All right, lesson check. Property for raising a quotient to power states that A over B to the nth power equals A to the nth over B to the nth. Property for raising a product to power states that AB to the nth power equals A to the n times B to the n. So how are the properties similar? And I'm going to say in both cases we are distributing the power to both variables, A and B. All right, that's it. See you tomorrow.